Hello all. Today I want to discuss a question from Biostat. I haven't added it as an MCQ. I want to just discuss certain concepts that we have in Biostat, especially regarding the relation between sensitivity, specificity, prevalence, positive predictive value, and negative predictive value. We'll see the formulas and how they're related. And if you haven't watched the video that I've already uploaded on Biostat, discussing all the concepts in the biostat that we can expect in exams. You can go watch that. I'll just put a link here in this video. So let's get started with this question. The screening test is used to detect disease X in a population where the prevalence of the disease is 10%, sensitivity of the test is 90%, specificity of the test is 80%. If 1,000 individuals are screened, how many individuals will test true positive? What is the positive predictive value? And if the same test is applied to another population where the prevalence is 1%, while sensitivity and specificity remains unchanged, what will happen to PPV? So we'll discuss each point in detail. Before that, let's see what are the equations that we have for sensitivity and specificity, and also positive predictive value and negative predictive value, because only once you understand that, you will be able to solve this question. Okay, so let's come to the 2 by 2 table that we know. Here we have the disease being positive and negative, and here we have the test result, whether the test turns out to be positive or negative. So if the test comes out positive for the patients who already have the disease, that is called a true positive. And if the test comes out positive for the patients who does not have the disease in actual, that's called a false positive. Okay, again, if the test turns out negative for the patients who actually has the disease, that is called a false negative. And if the test turns out to be negative for the patients who does not have the disease, it's called a true negative. So this is our 2 by 2 table: true positive, false negative, and true negative. Now let's see the equations for sensitivity and specificity. Sensitivity means it's true positive over true positive plus false negative. I've just added A, B, C, D in this table so that it becomes A by A plus C. So sensitivity is coming here. Okay, it's coming here. That is true positive over true positive plus false negative. That means if we have a high sensitivity, that means true positives will be very high, especially for diseases that are fatal, that have high morbidity, mortality. We need a highly sensitive test that can pick up almost all the patients that has the disease, right? So that is high sensitivity. That means it has a high true positive and a low false negative. So when we increase the sensitivity of the test, the true positive will increase and the false negative will decrease, because false negative is in the denominator. For example, if this test is 100% sensitive, that means we have 100% true positive. That means true positive will be 100 and false negative will be 0. We'll be having nobody who tests negative if at all they have the disease. But no test can be 100% sensitive and 100% specific. Okay, so you understand what is sensitivity. It is a measure of true positives. So if sensitivity increase, true positive will increase and false negative will decrease. How about specificity? Specificity is a measure of like true negative. So that means if the test is 100% specific, that means we'll have true negative as 100 and false positive as 0. That means we will not test positive for a patient who actually does not have the disease. For example, in diseases like HIV, where a positive test can be, a source of panic and anxiety in the patients, we need to have a highly specific test that do not have much of false positives. Okay, that means if the test turn out to be negative, then in actual the patient does not have the disease. It can be a true negative. Okay, that is called a highly specific test. So specificity is a measure of true negatives. If specificity is high, true negatives are high and false positives are low. So it is B by B plus D from this table. Okay, what about positive predictive value? Now let's come to positive predictive value and negative predictive value. Now positive predictive value and negative predictive value are measure uh, of the prevalence also. Okay, it has association with prevalence. However, sensitivity and specificity is a measure of that test alone. Okay, this is a measure of that test alone. It has nothing to do with the prevalence. But positive predictive value, negative predictive value will depend on the prevalence. We'll prove that in a while. So positive predictive value means out of all the positives, that is your true positive and false positive. So we are taking this. Okay, this. So out of all the positive, how many are true positive? That is your positive predictive value. A negative predictive value means out of all the negatives, how many are true negative? So it's true negative over true negative plus false negative. I've also given it in terms of A and B, that is A by A plus B, and negative predictive value C by C plus D. Now we'll give the values given in the question into the table so that we understand it better. So from the data given in the question, we have filled this table. Okay. So what is given in the question? The prevalence is 10%. That means out of the 1,000 population, 10% has the disease. That means number of deceased is total of 100. So total number of deceased is going to be 100. Now we'll fill the table using sensitivity. What is sensitivity? It is 90%. And what is sensitivity? It is true positive over true positive plus false negative. And we know true positive plus false negative means this total number of people who has the disease, right? So that is 100 in this case. So 90% means 90 over 100. That means the test will be positive, true positive for 90 people, and 10 people will have a false negative, because this is false negative, right? Actually has the disease, but the test turns out to be negative. So sensitivity turns out to be 90%. So we have filled the table 90 and 10. A total of 100 people has the disease. Now what is specificity? It is 80%. That means true negative over true negative plus false positive. So if 100 people has the disease out of 1,000, 900 will not have the disease in actual, right? So among that 900, 80% will be are true negative. So you can take it as 80% of 900, which will turn out to be 720, or you can just substitute the values here. 80% means 80 over 100. That is your true negative over true negative plus false positive. True negative plus false positive, this total value you know it to be 900, because that is the number of people who does not have the disease. So 80 over 100 is same as true negative over 900. When you substitute this will become 80 into 9. That will become true negative. That is true negative is 720. When you subtract that from 900, you will get as 180 as your false positive. Okay, so we filled in the table. Okay, from this from the sensitivity and specificity. Now let's come to the question. What were the questions? So the first question is how many individuals will test true positive? We've actually found that, right? So true positive, we have actually found that. What is our true positive? It is here. True positive is 90. So how many people will be true positive? It is 90. Next, what is the question? What is the positive predictive value? For that, we have to just substitute the values here. What is going to be positive predictive value? I'll write it here so that you can see. Positive predictive value. What is positive predictive value? It is true positive over total number of positive. That is true positive plus false positive. From here, what is the number of true positive? True positive, you found it is 90. This is your true positive and this is your false positive. So total it comes out to be 90 over 270. So positive predictive value is 90 over 270, or it is 1 by 3 or 33.3%. This is the positive predictive value. So from the sensitivity, specificity, we filled in the table, we found out true positive, we found out positive predictive value. Now let's come to the next question, because that is another whole concept here. If the same test is applied to another population where the prevalence is 1%, while the sensitivity and specificity remains unchanged, what will happen to positive predictive value? So we'll rewrite the table so that we can prove one thing. Okay, I'll rewrite the table and show you. So with the new prevalence, we have rewritten the table. Prevalence now becomes 1%. So 1% of 1,000 means 10 people have disease in total. So the total number of diseased is 10. Now sensitivity is again 90% because sensitivity is not dependent on prevalence. Sensitivity and specificity are not related to prevalence. Prevalence is a part of that population, it's a measure of that population. And sensitivity and specificity are characteristics of that particular test. Okay, so sensitivity remains the same. So 90% sensitivity is 90% means 90% of that 10 will become 9 as true positive and 1 as false negative. Again, doing the calculation, specificity remains the constant because prevalence has nothing to do with specificity. So 80% of 990 becomes 792, and the remaining is 198. So we've filled in the table. Now let's see what happens to the positive predictive value with this new table. So from this new table, new positive predictive value will be what? It's true positive over total number of positive, that is true positive plus false positive. So what is your true positive here? This one, that is 9. And what is your false positive? That is here 198. 198 plus 9, that becomes total number of test becoming positive, that is 207. So when we substitute and calculate, we get the new positive predictive value as 4.35%. Earlier we know it is 33.3%. So when the prevalence decreases, when the prevalence decreases, the positive predictive value also decreases. So that is the inference. Prevalence is directly proportional to positive predictive value and inversely proportional to negative predictive value. And you can prove that from the table. Okay, when the prevalence decrease, you will have less number of people testing positive. So positive predictive value will be less. Prevalence increases means positive predictive value will also increase. Okay, so what are the takeaway points from this session? So these are the key takeaway from this. So sensitivity increases means true positive value will increase and false negative value will decrease. Specificity increases means true negative will increase and false positive will decrease. Or in other words, highly sensitive test will pick up most of the patients who has the disease, and highly specific test will rule out the disease. So if the test turns out to be negative, you can be assured that the patient does not have the disease if it has a high specificity. Also, sensitivity and specificity are independent of prevalence. It has nothing to do with prevalence, but prevalence is directly proportional to positive predictive value. So if you have a high prevalence, positive predictive value will increase. So sensitivity and specificity are characteristic of the test, and positive predictive value is a reflection of the prevalence of the disease in that particular population. So from population to population, it will change. When you have a high prevalence, you have a high positive predictive value, and prevalence is inversely proportional to negative predictive value. So when you have a high prevalence, you have a low negative predictive value. So these are the key takeaways. Sensitivity is like a measure of true positives, and specificity is a measure of true negative. And for all the other concepts in the biostat which are important, you can watch the video that I've mentioned. And also, we'll be coming up with the ethics related questions in the next video, because there are so many questions that are repeated for EMREE from ethics, and there are only few points that you need to remember to tackle those questions. So let's see in the next video. Thank you so much.